Hello friends, welcome to TechEasy YouTube channel. In today's video, we are going to discuss the complete Linux process management. Okay, so first of all, let's try to understand what is a process. A process is a instance of computer program that is currently being executed. Or in simple word, we can say that in simple word, we can say that any program in execution is called process. Okay, program in execution is called process. Okay, so system D is the first process in RHEL 9, 8 and 7, whereas initd is the first process before the RHEL 7. It means in RHEL 5, 6, uh, init D is the first process, but nowadays system D is the first process. Okay, so during the life of a process can go through the different state. To get started with the various state of process, we can compare Linux, all this process state with the human being also. Like every human being has a different stages of life. The life cycle begins with the parent giving birth to an offspring. It means our parent give birth to us. And like a synonymous to a process being followed by its parent process. It means as our parents gave birth to the new child, uh, our Linux system D process also give birth to the child process. It means a- any parent process is going to generate a child process by using the forked function. Okay, so as after birth, humans start living their lives in their surrounding and start using available resources for their survival. Same in Linux also. When a process is in running state, then it utilizes the different resources to being in a runnable state, a running state, to be in running state. Okay, and during the utilization of resources, we process some data and generate some, take some input and generate some output. Okay, so at some point in the life cycle of humans, need to wait for something like some point of time as a human, we are waiting for some resources to perform our task. Okay, so in same manner, also our Linux process can wait for some resources for completing the some task. So this in this state, the Linux process are called in waiting, okay, are in called in sleep state. And just as every human life must come to an end, as every human life also come to the end, like uh, any born people have to death. Okay, uh, that is the last point of human journey. Okay, so as so our Linux process is also have a last state. Okay, which is in which state our Linux process got terminated. Okay, and declared as a dead, and his assigned PID is also no more. Okay, so in Linux process can be run into two mode, either in foreground, either in background. Okay, so foreground processes are dependent on the user for input, also referred as a interactive process. And second one is the background processor that's run independently of the user, also referred to as a non-interactive or automatic processor, such as Daemon. Okay, So we can also understand processes in different perspective. Like yeah, it can be also categorized in three types. Sorry, user processes, daemon processes, and kernel processes. What is user processes? So most of the processes in the system are user processes, and a user process is one that is initiated by a regular user account and runs in a user space. Okay, unless it is run in a way that give the process special permissions. An ordinary user process has no special access to the processor. Okay, and someone is also diamond process. Diamond process are the application that are designed to run in the background. Okay, like HTTPD, Chrome and many more services. Okay, what are the kernel processes? So kernel processes execute only in the kernel space, and they are very similar to daemon process. But only difference is that kernel process have full access to kernel data structure and algorithm, make them more powerful than daemon process that run in user space. So daemon process always run in user space. Okay, but kernel process has own kernel space and own data structure and algorithm access. Okay, so if you want to change any behavior of kernel process, then we have to recompile the kernel. Okay, so first of all, this is the most important thing to discuss the Linux process stack. As I already gave an example of a human being to understand it, but this is the now technical term. So a running or runnable process is represented by the R, capital R in our Linux, Red Hat Enterprise Linux. Okay, and if our process is in uninterruptible sleep, then it's denoted by D, and if it's in interruptible sleep, then it's denoted by yes. And if it is in stopped state, we can say terminated state, then it's denoted by D. If it's zombie, then it's denoted by Z. Okay, so as I already discussed with a human example, but here in technical term, we can also see that for any Linux process, their starting point this is the point where this process is created. For example, a parent process can initiate a child process using the fork system call. Okay, once it start, the process goes into the running or runnable state. While the process is running, it could come into a code path that require it to wait for a particular resource or signal before proceeding. While waiting the resources, the process would voluntarily give up the CPU cycle by going into one of the two sleeping state. Additionally, we could suspend the running process and put into the stopped state. Okay, usually this is done by sending the sleep stop signal. Okay, to the process. A process is in state will continue to exist until the killed are resumed with sig count. Okay, this is the basically signal. So these are the technical terms. So if you are not getting this point right now, then don't worry. We will discuss during the practical in detail. Okay. So the process completes its life cycle when it's terminated and placed into a zombie state until its parent process clear it of the process table. Okay. So this is the sample uh, infinite state. We can denote the process life cycle in this manner. Like a single process is created here, and it's now in running state, and then from running state, it can be go to the uninterruptible sleep. Okay, where it can wait for a resource and signal. And after when it's wake up by the signal, then it's return into the running state. And here it can also wait for a resource in interruptible sleep, where when it's wake up, then it's go to the runnable state. And also sometimes stop signal can be received for running or runnable process, then it's go into the stopped state, and then when sig count signal continue received, then it's returned to the again running state. Okay, so in this manner it's also can be uh, exited or terminated for permanently, and this is the basic life cycle of a process in Linux. Okay, so this is the most important file where all this is the file called probe etc probe. This is the file where sorry, not etc probe, it's a probe where all the processes we can see. Okay, so let's start with our practical. Okay, login into your either AWS EC2 RHEL 9, or you can use your on-premises RHEL, or you can use your VMware RHEL 9 machine for practical. Okay, as my RHEL 9 is started now, let's start with terminal. Name ES3. Okay, this command will show the are the process tree. Like here, you can simply see that system T is the first process here. Okay, and which started its child process, node manager first, and then network manager, then VG also it says, then accounts, diamond, then ultra CTL, then ETT, and then cronid and much of all. Okay, so it started in this sequence. Okay, so this is the basic PHP output. So, and the most important command for managing processes is PS. So, like here it's saying right now we have Bash, Firefox, and Socket process. Okay. So here we have all these processes running now. Okay. So let's check the output of here. Yes, I can have. Okay. Now this so the formatted information of running processes. Okay, so this is the same, but this and this is same. Only difference is the for formatting. Like it's so the UID also, PID also, and parent process ID also, and count size and residential set size, and also uh, process um, residential set, and start time and terminal and time and CMD. Okay, so here you can simply say that for Firefox it's running command is user lib 64 Firefox, and for bash its command is bash is running. Okay, now for if you consider for bash, then its user ID is like who which user is running this command is Saurabh. And what is the process ID for bash is 5558. And what is the parent PPA parent process ID is 5540. And what how many uh, basically CPU it's using right now is 0. And what is the size in what is the physical page size which it's required is 56027 bytes. Okay, and what is the residential set size for bash is 5712. Okay, and what how many processor it's currently used by this process is 0. And what is the start time? Its start time is 13 colon 37. Okay, it means in what we can say 137. Okay, as per IST. Okay, so right now it's running. Okay, so that's why it's not showing on the second timestamp. So this is the all information is stored by the PS-8. Okay, so I want to it show the current for Saurabh user only. So if you want to see information about all user, then we can put here either small e, either small capital A. Both are the same. Okay, so it show the all the users processes which are currently running in our OS. Okay, so let's check the PS-apps because some people use E app and some use AF. So both output are both the same. Only difference is one is the Unix format and second one is the BSD format for giving the command in PS. Okay, so this is the here we can grab as per our requirement. Like here we want to see the file information about Firefox. So here we can just grab okay Firefox. Okay. Now we can see that it shows the only information about the Firefox, like here, shown here. Now let's check one more output. Okay, yeah, okay. Let's see the another command which is jobs. It shows the current jobs which are running. It means process which are running in background. Okay, if you put bg command here, then it's a bg job one already running in background. Okay, it means this job is running in background because we uses the Firefox with and operator. Okay, like here we can say job one is in background. So if we use fg with one, this one from here. Okay, then it will come come within the foreground like here it's come in foreground, but right now we can stop or we can terminate it. Okay, as we put control C here. Now let's see the output of jobs command. Okay, now it's not showing any job is running in background. Okay, let's run two jobs in background. First run the Firefox. First we will run Firefox. Okay, for running any job in background, we can use the and operator after the command. Like here, I am running Firefox in background. And one more thing, okay, just keep it in background. Okay, we also want to run ping in background. Okay, and okay, output is showing here. So what we can do now, just stop this. Uh, right now, this is not stopping also with the control C command. So how we can stop this? Okay, as you can see. So for stopping this here, use F3 command. Okay, right now you can use the control C to stop it. Okay, so for saving the output, like here, if you want to save the output, then what we can do for the same, for achieving the same. So we can use the command here for solving the same issue. We can use the command no how, okay, followed by the hyphen f. No, sorry, no, we can use the no hub command followed by the command which we want to execute. Okay, right now in www.google.com. Okay, just it's saying it's going to no hub out. So let's stop. So when we cat right now with hyphen f, basically let's check first. Okay, okay. First of all, get the full path here. Like it must be in home. Sort of. Okay, it's saying what it's saying. Okay, we cannot use this. Okay, we can use the tail command for saying this. Okay. But right now it's only saying the static information. How we can see the all the dynamic output from here? Because when you use here job command, like jobs command, it's saying only Firefox is running, but it's not running the our ping command. So what we can do right now? We can just use the no hub with command like we want to execute ping. Okay, I want to ping google.com. Okay, and here we can use the AND operator. Now, let's see the magic. Now, just tell the output. Okay, now we can see the here we are able to receive the streaming output of the ping command right now. Okay, let's close this. It's Control C. Let's use the jobs command one more time here. So it's saying right now two jobs are running in background. Okay, first one is with Firefox and with the AND operator, and second one is no hub ping www. So these are the jobs which are running in the background, but these are the not the diamonds. So always remember all processes which are running in background is not a diamond. Okay, let's show. Let I will show an example of diamond. Is diamonds is okay. Like let's see the status of SSD. Like you can see that SSH is running right now, but it's not showing in the jobs list. Why? Because SSD is the diamond which is running behind the scene. But these are the background processes. These are the background processes which can be run in the foreground. But in but for achieving some objective, we are running it in background. Okay, we are intentionally running it in background. But these are the diamond like SSD, Chrome D. These are the diamond. This diamond does not support the foreground mode. it means it does not support the user interaction mode. Okay, but being with Google.com like here and Firefox support the user interactive mode. It can be in foreground or it can be in background. Like here, I will also job here. Let's make a job in foreground. For this, we can use the FG command. Okay, let I want to see FG2. FG2 will show, will do this ping www.google.com in foreground. Okay, we uses FG2. Okay, now it's in foreground. Not now. What we can do now? We can just we can terminate this by using the Control C. Okay, just here. Now we use jobs command one more time. What will show? It's basically we terminated this by using the Control C command. So when you use Control C command, then when it is in foreground, then it take the user's command. But when it is in background, it's not taking any user command. Okay, like here, one more job is running here. Let it in make it in foreground. So FG1. Okay, right now Firefox is also in foreground. Now we can also able to terminate this by using Control C. Okay, let we terminated this. And let how we can just kill a process by using the kill command. So just run a Firefox. Let's check need the job command also first. So here no jobs are running right now. Okay, so let make me a job running in the background. Firefox not running. Okay, now this is running with the PIG6973. Let's check the output of job command also. Let's check the jobs command output. It's not showing any job because we cut the Firefox. Let's run Firefox one more time in background. Right now, okay, just check the output of jobs. Okay, Firefox is running behind the in background. Okay, now let's take the ps hyphen ef or we can use the okay. Now we can grep can insist minor Firefox. Okay, now we can see that Firefox is running here right now. What is the main process for Firefox is 7587. Okay, let's try to kill by using the PID kill 7587. It's saying no processes. So what we can do right now? Let's try to close the 7267. So use kill 7267. It's then ejecting due to channel error kill 7267. It means now our kill command is successfully run. Let's check one more time the jobs command output first of all. Okay, now we terminated by using the kill command to Firefox. So why it's not terminating by the 7587, but it's terminated by the 7267. So here we can see that this is the actual location where Firefox is running. It means this is the parent process of Firefox, topmost parent process of our Firefox. Okay, but what we will see here, these are the not the parent processes. Okay, or this is the just a what is this? This is just a way which we run the when we run the ps command, then this is the only just that. Okay, right now we already know how we can just use the ps command, kill command, and drop command, bg command, and fg command. Okay, but how we can just find the process ID of any job? Let me create a first. Let I want to know process ID of system D. System D. Okay. Now it's showing the two process IDs for system D. So lesser one is the main, like when we execute PID of system D, then here we get the two process IDs, 2280 and 1. So this is the process ID for system D. Let I want to just use I want to just see the several resource utilization by the processes. So we can just use the top command here. Like it's showing the information. So in top command we can see that it's showing process ID, user, PR, nice value, virtual memory, resident, set size, and SHR value, and the current s- status of process, current state of process, and CPU utilization, memory utilization, time, and command which we are which is executing. Okay, as we say that one is the here we can see that process ID one is associated with the system D. Okay, as we can see that. But right now, what we can do with this command, because top command is very vast, so we can we can do many things with the help of top command. Like we can specify a nice value if we give the R command, and we can specify a nice value like here it's renizing the file process ID 5540. So here we can give the value from okay, what I say. It's basically a specified range of value from which we can give. So let's give the nice value 10 here. Okay. Now we can say that associated value is renized. But here we can also like for here we can use the capital C for showing the complete path. We can use the yes for changing the refresh rate. That is changing in 3 seconds. Then we can change it to the 5. Okay. Right now it will refresh after 5 seconds. After every 5 seconds. Okay. You can see that. You can notice right now. And here we can also use like if you want to start with the uh, memory by memory, then here we can say that it's basically now sorted by the memory utilization, like highest to lowest. You can see that. One more time. Okay, this is now right now sorted in when we press Shift M, then it's sorted by the memory from higher memory utilization processes to lower utilization. And when we use the Shift C, okay, then sorry, we can use Shift C, but also we can use the Shift P. Right now we are going to use Shift P. Okay, when you use Shift P, then it's basically sorted in order of the CPU, or you can say the by the processor. If you want to sort it by the nice value, then here we can just press Shift and like here it's sorted here right now, and we can also use the many more commands are present. You can just man the top first saying this. Okay, we can use Q command for quitting the top. Okay, so right now we quitted the top command output. We can also use GUI based. We can say the alternative of task manager or alternative of top command. We can when we have genome based GUI installed, then we can just use the genome system monitor command. Genome system monitor command. This command will show. Okay, sorry. Okay, this command will show all the same information in GUI format. Okay, right now as we can see that here this is an alternative utility or Windows Task Manager which we can use in Linux, in which we install the genome GUI. Okay, right now as we can see that here this is sorted in highest to lowest utilization manner, and this is the user, the how many it's using the basicalities. We can see that right now. What is the priority value? Like it's normal, and what is the disk read total, disk write total, and what is the memory utilization right now, and what is the ID, process ID means. And here we get also option of ending the process, and also similar option like you can see the properties and many more information come here. So here we can see that we can directly open file, we can change the priority, we can set affinity value, or we can stop, we can continue, we can end, or we can kill this process. Here in resources section, we can see that uh, graphical view basically of CPU utilization, memory utilization, and network utilization. Okay, right now you can see it here. And here in file system section, we can see that all the file system, how many file system is utilized, and how many available, and how many is used. Okay, and what is the type of, and what is the directory where it's mounted. Okay, right now you can see that by so this is a very good utility. You can just check it out for managing all the processes. You don't need to if you install GUI. It means if you run in GUI targeted mode, in graphical targeted mode, then you can use this utility also for managing the Linux processes. Okay, so right now I am closing this GUI based utility. So this is the I think best utility which you can utilize. You can also utilize. Let's here is the output of job. So no jobs are right now running. So here we see how we can renice. We can also use the direct renice command for renizing any process. Okay, like if you want to renice with -10 to for which process, just let yes, in this is yes, I can. Okay, we want to just renice value. So as per your, it's not required, but here I will show a just command like you can renize the value. It's not recommended, but I just want to show you how you can renize. Okay, just I want to renize this process ID. Carbase. This is process ID is 5558. So it's saying fail to set priority for further process ID permission denied. Okay, why permission denied? Sudo. Okay. Right now it's changed, priority is changed. Old priority is 0, it's saying old priority is 0 and now new priority is -10. It means it's get highest priority, but priority is also nice values to two types. First one is user defined nice value. Here I will show in notepad. Like nice value are also two types. Nice value are two types. User defined nice value and second one is the you can say system defined or kernel defined. System or kernel define nice value. Okay. So when we use command, very nice command, then we are just changing the user nice value. Very nice command only change the user nice value for a process. Okay. So this is important thing. We are not able to change the system or kernel defined nice value. We are just only able to change the uh, only user defined nice value. Okay, how many nice value we can give? So range for nice value is like range is okay. Range is from -20. -20 is highest priority. -20 to how many priority we can change? We can assign it to the 90. Not it's not -9. It's 90. Okay. Lowest priority. It means lower will give lower has highest high priority. Okay. So this is all about nicing and renicing. So in same manner we can change the nice value for any process. Okay. So what we can do more with the process management? Here, process management is very vast. But here, let I will run Firefox for example in background. Okay, now right now Firefox is running. Okay, in background, we can see it in job. Okay, let's check the EID of EID of Firefox. Okay, it, it's giving the many PID, but which one is the main one? Lowest value is always lowest. If you have to consider the main PID of Firefox, then we will consider the lowest value because all these are the interdependent on the PID 7746. Okay, so if you want to kill the only specific process, like if you want to kill Firefox, then you can just use the kill command with the like here we can also give the signal like a kill nine signal for terminating. Okay, like here we will using the terminate signal. So it's basically terminated the Firefox. Okay, let's see the jobs command output. Okay, it will showing it's basically terminated the Firefox. Okay, we can also use the like signal for starting a process uh, starting a basically command, not any process. Because program running when we run a command, then it's a starter. It will make a process. Okay. Right now, if you want to kill all processes of any user, then what we can do? We can just use the kill all command. Okay, with -u and username. Right now, I want to kill all processes of user sorrow. Then what it will going to do? It's basically if I execute this command, what it will do? It's terminated all the command which are running, which are run by the user Saurabh. Okay, so it's sign out. Hmm. Okay, so this is the very critical command. I hope you are not going to run in your production environment. So it's just for demoing you how you can use your kill command. Okay, I hope I will show this. Okay, let's one more topic is also here. The concept of thread. What is thread? So sometimes you hear about the threads, like threads. What is this threads? So lightweight process is known as thread. These are the smallest unit of a process. Smallest stream of a process. Okay. How we can just see the uh, thread of any process? So let's run the Firefox again. I am using Firefox for example because Firefox. Okay, I run the Firefox in the ground. Okay, now we can check the output of jobs. So I want to check the threads for Firefox. So what we can do, I just can give the one parameter with ps command. We can now, okay, first of all, I have to check the PID of Firefox. Okay, we right now check the PID. So we will consider 9417 is the main PID. So yes, we want to see the thread. Okay, ps hyphen t are showing me the thread. For which process ID we want to say 9417. Okay, now it shows us all the threads. Okay, all the threads are PID 9417. So these all are the thread and these all are the thread IDs. Okay, you can see here right now. So what we can use here also, we can just use it with hyphen f in association with hyphen f command. Right now we can see that the more information about thread. So this is the actual process ID and this is the child ID or we can say the threads ID or process ID 9417. So these all are the threads and we can see the all is located in Firefox lib64 user lib64 Firefox. Okay, so these all are the thread. So when we terminate a process, then all threads is also going to terminate. But sometimes uh, some threads are not terminated because of the some misconfiguration written in the code of Firefox or any other utility or any other program. So it's create a zombie zombie program, zombie processes. Okay, so some zombie processes are represented by the jet. But right now, if you want to just search for the zombie, like here, we can also just here we can grep for let grep for jet. Okay, okay, it's not showing any zombie. Okay, here. So let's check in complete system. Let's check. Okay, grep. What we want to grep zombie process. Okay, okay, okay. So in this manner, we are not able to grip the zombie. But sometimes its knowledge is required. Sometimes it's not clear the record in page table. Okay. So that's why it's create. It means zombie process. Zombie processes are also known as the orphan processes. Sometimes also one more name is also given to the zombies processes. Okay, so that it. You can also check the manual for PS command, and you can read about some more options which you can use. Like here, many more options is also present here. So let's quit here. We can also read the main of prop command here. Okay. So this is the very big command. So you can consider it to run it. But for daily usage, I think I shown all the command which are right now in my mind. So I am completing this video right now. So thanks for watching this video. See you in next video. Thank you, friends.